Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Okay, so today we are going to proceed to another part in the UV spectroscopy. So last class saya dah discuss in detail. So I hope that you can go through again the lecture note and also you can have any resources uh, to know more about what is UVs. Okay, so saya dah discuss this one and regarding the principle. Okay, and also the most important one is regarding the type of the transition. So today, like I already mentioned, in this video lecture, I will try to discuss more on the instrumentation and also we call it as a one law that related to the UV spectroscopy. We call it as a Beers-Lambert law. Okay, so you can go through in the lecture note at a certain slide ataupun kita kata pages mana. Okay, but mungkin ada yang saya tak discuss in detail in this video, so you know that that's will be, for example, the type of detector and so on. So I will not going to discuss in detail in terms of the mechanism and so on. So that's extra, or we call it as the additional knowledge that you can read on your own punya knowledge lah. Okay, boleh baca lah. Okay, so when we talk about the instrumentation, so that means this one, I believe that you are quite familiar, even though you didn't meet yet the UV spectrometer, but soon when you are going back to the UPM, I think that you have chance to meet this one, this instrument, because it's a very most widely we call it as a spectroscopy instrument for the qualitative and also quantitative. Okay, so usually it will start with the sources, or we call it as a source. This is light source. When we talk about the UVs, so you supposed to know that it will start with the source, and then you supposed to know this one we call it as a monochrometer. And then it will go to the sample, we call it as a sample location, or this is the place that you have to put your sample. And then of course after that we have a detector to detect the absorption, right? Because you know that when we talk about the UVs, it's talk about the absorption spectroscopy. And the last one, it will be the computer lah. Jadi kalau you tulis computer pun tak ada masalah. The readout, or we call it as this is the place you have to collect your data, your spectrum. Okay, so that means this arrangement is very important. So you cannot put the sample first and everything and then it goes for the detector. You have to follow all the sequence. If the question asks you to draw the schematic diagram. Schematic diagram mean yang petak-petak macam ni lah. So that mean even though you are going to meet the instrument later, so you akan nampak the correlation why the sources have to be at the first place, and then it goes to the monochrometer, and then place you put your sample, and then the detector, and the last one is a computer. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 5 components. These are very important. Okay, so you know that for example if you have source, okay, so saya hanya beritahu a very we call it as the brief. Lepas ni saya akan discuss quite detail how it works, okay, in the instrumentation itself. Okay, so when we talk about the source, so you know that this one is to produce the electromagnetic radiation. So that means the electromagnetic radiation, so usually in the range of the UV and also visible lah. Like I already mentioned, it start from 200 until lebih kurang dalam 800 nanometer macam tu, right? Because I already explained UV and also the wavelength for the visible also. And then when you have a monochrometer ni lebih kepada we call it as a wavelength selector. Okay, so what does it mean? So that means you know that you have the light, okay, this is the sources to produce the electromagnetic radiation, or we call it as a light. So the light will pass through, okay, because it can pass through with various wavelength. Okay, but the purpose of the wavelength selector, we call it as a monochrometer. Nama dia pun mono, so that means it will choose the best wavelength that can be absorbed by the sample. Okay, jadi sebenarnya selalunya kita akan ada, we call it as a beam. Okay, beam separator to select the best wavelength that can fit with our sample lah, molecule in our sample lah. Okay, so this is a sample. So that means this is a sample holder. Kita boleh kata this is the place that I have to put the sample. Ataupun we need something, right? To hold our sample, for example, right? It's quite easy to understand. And then once the absorption occur, okay, so you know that once the absorption occur here, so it must be the detector. Why? Because to detect our sample ataupun to detect the absorption, to convert, right? Selalunya kita kata this one to convert the radiation energy to electrical energy, so that it can be calculated and then come out in the computer. So this is where the data is coming out, ataupun kita kata our spectrum. So dekat sinilah akan keluar yang kita collect dan sebagainya based on our wavelength and also absorbance, for example. Okay, so these are, we call it as the brief introduction on the components in the UVB spectrometer. Okay, so kalau saya boleh pergi detail, okay, so supposedly for example, okay, kalau kita kata kita start with the sources, for example, kalau kita kata kita ada contoh, kalau saya boleh lukis kat sini, for example, you have a light kan, okay, so usually the light that we are using, sama ada kita guna deuterium, okay, deuterium light, okay. So usually how the deuterium is working, so biasanya akan berlaku emission of the radiation, so that okay, it can the light can pass through, right, into the monochromator, okay, to be absorbed by the sample. Jadi kalau kita kata kat sini, so we have the light source, yang mana the light source usually, for example, deuterium, there are many types of the light. Okay, one of them will be a deuterium. And then after that, you know that it will go for the monochromator, like I already mentioned before. Okay, so usually in the monochromator, okay, jadi kalau kita kata kat sini, this is a monochromator. And then after that, it will be connected, ataupun kita kata this is the beam separator, yang mana beam separator ni dia akan okay, separate, dia akan separate kepada dua, okay, yang mana we have one here and then we have two, okay, so this one we call it as a sample holder, yang mana one we have to put the reference, okay, nanti bila biasanya dalam lab kita akan explain lagi on this one, you akan nampak lagi lah based on the video yang kita akan tunjuk, right? Okay, and then it has to be connected into the detector, right? Of course, why? Because we want to detect. So that's why the last one kita ada computer lah. Okay, so for example here, you know that, so you have a light source, you know that the light source is to produce the electromagnetic radiation. After that, you have a monochromator. Selalunya, okay, for example, this light source will go through, and then from that, you know that there will be a various wavelength. Okay, so monochromator ni, monochromator sometimes it will be grating punya type, it can be prism. Contoh kalau saya boleh lukis kat sini, for example, it's a prism lah. Okay, so that means this prism, okay, for example, so it will be having various wavelength, right? Because you know that the light source will be lies in the, for example, UV's punya range, and then this has a monochromator, but the function of the monochromator, okay, is to choose, we call it as to select the best wavelength that can going through, okay, into the chamber. So dekat sini kita ada two different chamber, yang mana one chamber will go into the reference, one chamber will go into our sample. So dekat sini kita kata beam ataupun light, light separator. Okay, so I hope that you understand. So you have the light and then it will go into the monochromator. There are many types of the monochromator. One of them is the prism, for example, prisma. And then it will go. So this angle ni kita boleh adjust lah. Selalunya this angle kita boleh adjust towards which wavelength that's suitable with our sample. So that's why the one that coming out tu daripada berapa sampai berapa, for example. Okay. And then it will go into two different sample holder. So here, one is we have to put the reference usually our solvent, and then one of them is our sample. Okay, so usually this one selalunya dia akan ada satu, we call it as a cuvette. So this one we call it as a cuvette. So cuvette, there are many types of the cuvette. For example, we have plastic. Dulu kita pernah guna plastic, and then sometimes we are using glass, and then sometimes we are using quartz. Okay, it same goes to here. Okay, but the most widely used is the quartz. So usually we have to make sure quartz ni bersih. Okay, before we put our reference, for example, our solvent and also our sample. Okay, so usually how to put the cuvette? So usually the cuvette ni dia akan ada the different side. Satu side yang very transparent, satu side yang so for example bukan satu side dia dalam bentuk macam ni, macam tu kan. Okay, jadi ada dua side, nanti boleh tengok dekat YouTube nanti So dia akan ada dua side yang belakang depan tu. Okay, belakang depan tu mungkin yang transparent, dua side lagi yang gelap. So macam mana you nak put the cuvette is you have to make sure that the transparent will be dekat side macam ni. Why? Because we want to allow the light going through into the quartz cuvette ataupun going through into our sample. Jadi dekat transparent side mesti kita letak dekat sini lah. Okay, kiri kanan, so that the light will be going through, will be transparent and going through into our sample. Okay, and then the last one, of course, we have a detector. Okay, so the one that I want to stress here, other than that, okay, so you have to imagine that, for example, if you have a sample, in the sample, you have the molecule. Okay, you know that if the molecule, okay, it has the electron, when it absorbs the electromagnetic radiation, okay, so it will be having a transition. This is the one that I already mentioned. Okay, so jadi kalau you masih ingat, jadi you have a electron will jump from the ground state into the excited state. So dekat sinilah akan ada absorption yang berlaku. So berapa banyak energi yang dibunuh. Okay, so datang daripada mana energi ni? Datang daripada this one lah, the lightning. Okay, so I hope that you can try to imagine. For example, if you just put the reference, so for example, this is just the solvent, not involving your sample. Okay, jadi for example, you just using a water lah, kita kata water. Jadi selalunya in a water, okay, there will be, water is a molecule juga kan. Jadi it will be a transition, but usually the transition happen in the water, okay, lies less than 200 nanometer. So dalam arti kata lain, when this UV-Vis punya light, electromagnetic radiation, going through into the chamber and then going through into the solvent, so kita boleh katakan there is no absorption occur sebab dia tak termasuk dalam range UV-Vis. Okay, jadi apa yang kita kata, dia hanya lalu, tiada absorption yang berlaku. So that means the intensity original, okay, that source by the light sources ni, okay, tetap sama. Betul? Contoh kat sini ada berapa? 100%. If we can take it in the percentage, 100% light source going through, so 100% lah yang akan keluar. Why? Because there is no absorption occur. So dalam arti kata lain, dekat sini kita panggil I note, intensity original. Sebab itulah kita perlu letak reference so that we know there is no absorption occur, and then we know that the intensity have to be, for example, similar with the one that supplied by the light source. Okay, so I hope that you understand. Okay, for example, you have a sample, but for the first time, okay, mula-mula you nak test kan, okay, you put the sample pun sama juga. You try to put just a solvent, similar with the reference. So, apabila there is only water ataupun solvent, sama. There is no absorption occur. So that means the intensity that provide by the sources similar. Okay, apa yang masuk, itulah yang keluar. Okay, dekat sini we call it as the intensity that come from the sample lah. But if we are using sama, solvent dengan solvent, okay, water dengan water, so automatically you can say that intensity original, okay, it will be similar to the intensity of the sample. Sebab sama. Okay, so this is the first case lah that I can give an example. But For example, reference, you put the water. But in the sample ni, contoh you kata you try to put the caffeine lah. Macam kita kata yang last week kita tengok tu. So you know that in the caffeine, there are many electronic transition can happen. And then usually it will involve the UVBs punya, lies in the UVBs punya range ataupun spectrum. Okay, so you know that there will be possible absorption occur for the caffeine. Okay, your sample, for example, caffeine solution lah. For the reference, so you know that there is no absorption occur, so automatically I node will be original. But at this moment, you can say that I node will not similar to the I sample. Why? Because you already put the caffeine solution. In the caffeine solution, there will be absorption occur. Yang mana apabila absorption berlaku, so you boleh bayang contoh 100% supply, light supply, and then absorption berlaku mean, okay, the electron guna untuk jam dan sebagainya. So you can assume that the intensity yang keluar ni berkurang. Do you get what I mean? So jika, okay, if absorption happen, okay, so intensity of the sample, saya panggil sini will be lower. Sebab apa? Sebabnya intensity original yang masuk tadi telah digunakan, is already been utilized by the molecule in the caffeine to go for the absorption. Because akan berlaku absorption, dia akan ambil sikit energy tersebut, light tersebut, so that yang keluar pun sikit lah, because some of them is already have been utilized ataupun have been consumed by the caffeine molecule, for example. Okay, so dalam arti kata lain, okay, this one we call it as a transmittant. Okay, transmittance, yang mana transmittant is equal to the I over I naught. Okay, jadi kalau you boleh tengok dekat sini, this is a transmittance punya equation. Jadi apabila tengok transmittant, please jangan confuse pula. Transmittant ni apa pula kan? Transmittance mean the intensity. So you can say that intensity that come from the sample lah, over the intensity original, which is come from the reference, the one that you want to compare. Okay, dalam arti kata lain, if the value of the transmittant is higher, betul cuba dengar baik-baik. If the value of the transmittant is higher, automatically the value of the intensity sample is higher. Betul, kalau ni tinggi, mestilah ni tinggi. So you know that the absorption berlaku pun sikit lah, decrease lah. Dapat? So sebab apa dia tinggi? Sebab absorption berlaku sikit, so that dia guna sikit saja intensity original yang dikonsume ataupun diberikan, okay, have been that provided by the light source. So that's why yang intensity yang keluar ni banyak. Why? Because absorption berlaku sikit. Okay, so it will be the correlation between transmittant with the absorption. Okay, dalam arti kata lain, kalau you try to connect with this one, if transmittance is higher, so automatically absorption will be lower. If the value of the transmittance is lower, the value of the absorption is higher. Okay, jadi boleh nampak lah. Jadi kalau banyak absorption yang berlaku, yang keluar, intensity keluar, mestilah sikit sebab banyak dah yang telah digunakan. Apabila intensity yang keluar ni dah sikit, automatically sini sikit, automatically transmittant will be lower, right? But if the absorption occur but is only utilize very low energy, okay, energy yang dia guna sikit saja, for example, so that mean yang transmit ni, intensity ni banyak, so automatically the value of transmittance will be higher. Okay, jadi dekat sini I want to make sure that you really understand on this part. Okay, so if you want to relate absorbance lah, kita panggil absorbance. Okay, absorbance, if you want to calculate from the transmittance, is equal to negative log, okay, T. Ataupun absorbance is equal to negative log, what is T? I over I naught. Okay, so you're supposed to know the correlation between transmittant with the absorbance. Sometimes we can calculate the transmittant. From the transmittance, we can calculate the absorbance. But you know that the purpose of doing all this, for example, kita cakap pasal caffeine, you want to know the concentration, right? Berapa banyak amount of the caffeine. Jadi how we want to relate, okay, kita dah tahu correlation between absorbance with the transmittant, but what happened to the absorbance with the concentration? So that's why we have to go for the Beers-Lambert law. Okay, so what is Beers-Lambert law? Okay, so you know that Beers-Lambert law is equal to the A is equal to the, okay, epsilon BC. So what does it mean? A is the absorbent, so you know that, okay, absorbent. Okay, so datang daripada mana absorbent? So you can get it from the transmittant by calculating I over I naught dan sebagainya. Okay, this is, we call it as a molar absorptivity, yang mana molar absorptivity usually constant. Okay, selalunya ada nilai yang tertentu based on the molecule, for example. And then you have B. What is B? B is the path length of our sample, yang mana selalunya when we talk about the cuvette tadi, okay, kita kena tengok berapa jarak cuvette yang selalunya we are using 1 cm. Okay, so B is the length of the light that going through our sample. So you know that because we put our sample in the cuvette, so automatically B will be the length of the cuvette. Okay, the kelebaran, kita panggil kelebaran cuvette tersebut. C is a concentration. Okay, jadi dekat sini you already have an idea. For example, you have the value of the absorbance, right? You already have the value of the absorbance, datang daripada absorbance, so you can calculate from the transmittant, sometimes you can get it from the peak dan sebagainya. Okay, and then molar absorptivity automatically, like I already mentioned, this is constant, okay? And then you know that B, so usually 1 cm because the kelebaran of the cuvette, the one that we put our sample in, right? So automatically we can calculate C. Okay, jadi apabila kita nak tahu apa itu nilai C, automatically you know that absorbance over molar absorptivity multiplied by the path length, for example. So automatically you can calculate the concentration. So that's why apabila we try to relate, okay, for example, you want to plot what is the correlation between absorption ataupun absorption selalunya kita guna. If you want to calculate it in the percentage so that it easy, you calculate the absorption and then you have to multiply by 100 so that you get 100% lah in percentage. And then you want to relate with the concentration. For example, this is not the spectrum. Spectrum is the one that you get from the UV ray study dalam bentuk peak dan sebagainya. But this is the one that you want to know the correlation based on the Beers-Lambert law. Beers-Lambert law say when the absorption is higher, automatically the concentration will be higher. Okay, jadi apabila you try to plot the concentration, you have 1, you have 2, you have 3, you have 4, you have 5. So for example, concentration in the ppm unit. So apa yang you boleh bayang adalah it has to be something like this. Why? Because you have to go back to the Beers-Lambert law. Okay. For example, when the concentration is increased, automatically the absorption value will be increased too. Okay. Jadi apabila you try to relate, for example, if you want to plot the graph, okay, this is the graph absorption lawan concentration, right? Contoh kalau you kata you nak ada graph based on the transmittant, right, with the concentration pun boleh, tak ada masalah. Why? Because once you know the value of the absorbance, automatically you can calculate the transmittance, right? Okay, jadi contoh you kata you nak ada correlation between transmitted percentage pula kat sini with the concentration. Can you do that? Yes. The answer is yes, tapi you can expect that, okay, the peak something like this lah. Semakin ke bawah lah. Why? Because semakin tinggi concentration, semakin tinggi absorption. But you know that absorption dengan transmitted it always opposite. So peak yang kita akan dapat adalah dua jenis peak yang berbeza. Okay, so I hope that you really understand on this part. So this is a correlation between the instrumentation, and then we can try to connect with the absorption, and then you have to know what is the Beers-Lambert law. Sometimes in the exam, dia akan tanya benda-benda macam ni yang mana you have to explain what apa yang you tahulah. So please cuba faham instead of hafal. Okay, so I think that's all for this video lecture. Okay, so I hope that you can answer a few questions that related to this one. Of course, next week during our class, so you can ask any question if you have any lah. So thank you very much.